Morning to one and all present here. This is Mr. A. Appu, Assistant Professor from Miyasi Institute of Management. And today I'm going to be discuss with a course. It's called Resource Management Technique, which is it's called as Applied Operation Research. So there are so many techniques available in Applied Operation Research. In this slide, I'm going to be discussed with one of the important famous technique that's called about linear programming problem. I'm going to be sharing with you. So before going to linear programming problem, I just want to know about what is the name of the subject we are going to be discussed. That's called about applied operation research. So once when you go for the term called AOR, that basically talks about a study of optimization technique. So what do you mean by optimization? The optimization means you are going to be select the best from the options available with you. That's called about optimization. For example, you can take it about a marketing manager of the company. He has been provided with the manpower. He is having money and he is having machines and he is having a number of resources. He is going for giving a new advertisement ad for a particular products which is a very branded one in the market. So with the help of the resources, how he is going to be give maximize the profit and how he is going to be minimize the cost. That concept is focused as optimization. And in this slide, we are going to learn the concept of linear programming problem. So in this slide, I've been mentioned certain things, what is called LPP, that's called linear programming problem. And what about the main elements present in linear programming problem. So before going to the component, first we should know what do you mean by LPP. So LPP is nothing about one of the technique of applied operation research that is framed as the mathematical model which is going to be allocate the resources like a manpower, money, capital, everything to the service as well as the project. So in case of the linear programming problem, there are basically four components will be existing. One is called as a decision variable, which is always called as a structure variable. So the decision variable is nothing about what the company is going to sell the products in the market. That we are going to be defined as in terms of quantity, which is a uncontrolled one, which means the company can go for n number of products to sell in the market. For example, the company, if they are going to sell pen as well as a pen in the market, these two things will be noted down as decision variable, which is always called as structural variable. So after finalizing the two product, what the company is going to be sell in the market, they have to be framed what is the goal of selling the product. The term will be called as objective function. So the objective function is nothing about either the company is going for how much profit they are going to be get because of pen and pencil, or how they are going to be minimize the cost involved for this product. The term will be called as objective function. So the decision variable which is going to be present in this problem can be rewritten as the objective function. Third is nothing about a condition. If you are going to be sell the two product, pen and pencil in the market, the manufacturer or the dealer, they have certain condition within the certain limitation they are going to be sell the product. What about the manpower capacity? What about the raw material? How many days they are going to be work? How much salary they are going to be given to the labor? All the thing we are going to be take down as the restriction, which is always said to be a constraint. So whenever the condition expressing the relationship between the variable, the term will be called as a constraint, which is a controlled one, because within certain condition how effectively you are going to be utilize the limited resources, that part will be termed as constraint. And finally we are going to find out the non-negative constraint, which is nothing about what is the value of the result we are going to be get. We are going to be sell the products of pen and pencil in the market. So that product is going to be give anyway profit, or it's not going to be a zero, or it's going to be a 0 1. So it's not going to be a non-negative one. So that term will be called as non-negative constraint. So finally, once when you come to the definition of linear programming problem, the linear means that basically talks about the relationship between the variable that is basically present in the problem. That's called about linear. Programming means that basically focused about the plan of action, how effectively you are going to be allocate the resources to the particular product. So the ultimate goal of learning the linear programming problem is finally deciding about optimization, which means how you are going to be effectively utilizing your manpower, the raw material, the machine, the labor, and what are the budgets available effectively within the certain condition. You are going to be find out the goal, either going for maximize the profit or going for minimizing the cost factor. And the previous slide we discussed about what do you mean by applied operation research. So as I already said, the OR is focused about optimization. So in case of this concept, the linear programming problem, we are going to be find out how to derive a best solution for the product which has been handled by the marketer. In the next slide, I am going to discuss about the basic real problem, how the concept of LPP will work out. Yes, now we are going to take a real life business problem. For example, you can take it about a dealer. He is going to be sell two products in the market. One is nothing about a table and second is nothing about the chair. The dealer is going for two condition. One is nothing about he is going for investment of rupees 50,000. Second is nothing about the space available for the dealer is nothing about he can keep only 60 pieces. Either it may be a table or it may be a chair or it may be a combination of table and chair. And in order to prepare one table, the cost involved is nothing about 2,500, and in preparation of the chair, the cost involved is nothing about 500. And next is nothing about in the problem they're giving about the profit part. Because of one table, the dealer is getting 250 rupees as a profit, and because of chair he is getting 75 as the profit. So now we have to determine how many table and chair the dealer can prepare with this limited resources. The limited resources is nothing about, one talks about the investment part and second talks about the storage facility available to him in order to get the profit. So this is the way we are going to be considered as a real life business problem. So in case of this problem, there are basically three things will be involved. One talks about the condition, second is nothing about the decision variable. Here the decision variable is nothing about, one is nothing about the table and second is nothing about the chair, and the dealer is mainly going to be focused about maximizing the profit. That's going to be your objective function. So before going to be use the concept of a linear programming problem, we can go for taking as a general calculation. What will be the different optional cases arise for this problem as the profit part. So from the previous slide, we come to know about some hints has been given in that real life situation of the problem. One is nothing about the investment which has been given in the problem, that is nothing about 50,000 has been given. Second is nothing about the storage space is nothing about only 60 pieces. There's a two condition which has been given in the problem. And now we are going to be find out what are the different situation arise as a profit to the dealer. For example, if the dealer is going to be focused only about a table and no chair, the total number of investment is nothing about 50,000, and in order to prepare one table, the value of the cost is nothing about 2,500. So this will gives only 20 table. So because of one table, the dealer is getting a profit of 250. So 250 into 20 is nothing about 5,000 will be the profit the dealer will be getting if he is going to be sell only the table. This is one case we are getting from the above problem. And now come for the case number 2. The dealer is going to be focused of selling only the chairs and is not going to be focused about the table. So the initial capital investment is nothing about 50,000. So 50,000 divided by the value of preparing one, that is chair is nothing about 500. So maximum he can prepare 100 chair with the initial investment of 50,000. But once in this problem the storage allocation has been given only for 60 pieces, so it can be prepare only 60 chair. The remaining 40 chair is not capable of kept in the particular store space. So 60 into 70, once when you are multiplying, in case of this case number 2, he is getting a profit of 4,500 if he is going to be focused only on chair and not focus on the table. This is the second the case arise the profit about the given information. Third is nothing about we can see different permutation combination. Since the condition is nothing about 50,000 will be the investment, and the maximum number of storage of tables and chairs go for only 60 pieces, you can go for different combination. Either you can go for 10 table and you can go for 50 charts, you can go for 20 table, 40 charts, 30 table, 30 charts, like that. A different combination may be exist. If I am going to be considered only 10 table and 50 charts, here then is a profit is nothing about 6250. So this is the maximum the output based on the problem we are attaining. So from this problem, the information given as a condition, investment as well as the storage, we are deriving certain profit. But this, the general calculation, we are going to be find with the help of our linear programming problem. So before we are going to be convert this real life problem into the linear programming problem, we have to be frame certain component for linear programming problem. One is nothing about what is the decision variable, what is the objective function, what is the condition, and how many table and how many char the dealer can be produced with this condition. That we are going to be discussed in the next slide. And now I am going to be convert the general problem into the linear programming problem. For this I need a certain input. The input is nothing about, one is nothing about the decision variable. So here the decision variable is nothing about the dealer is going to be sell two product. One is nothing about the table and second is nothing about the char. So I am going to take x as the table and y as the char. This is one of the decision variable I am going to be frame in this problem. Second is nothing about the condition. Right here the condition how I am framing means x represents the table and y represents the chart. The first condition is nothing about the investment. In the previous slide, the investment, they are the dealer is investing 50,000. So for the preparation of one table, the cost involved is 2,500, and for the preparation of one chair, the cost involved is nothing about 500. So on taking this as a condition, I am going to be frame the equation as 2500x plus 500y less than or equal to 50,000. That can be represented as the investment condition. This is one of the condition, which means the investment is going to be only up to maximum 50,000, and the dealer has to be prepare table and the dealer has to prepare the chair, and for preparation of one table the cost involved has been mentioned as 2500x as well as 500y. This is nothing about the investment part. Second is nothing about the storage. Maximum you can keep 60 pieces. So the minimum number of table and the minimum number of tar can be represented as x as well as the y. So second condition is nothing about that basically talks about the storage base. That is the second condition we are going to be utilized in this problem. And what is the main the profit motive of the dealer, which means we are going to be frame as z is equal to 250x plus 715y, which means 250 is nothing about the profit he will be getting because of one table, and 75 is nothing about he will be getting the profit because of one char. And now ultimately what we are going to be find out, we are going to be find out the value of x and y, which means we are going to be find out how many table and how many char can give maximum profit to the dealer with the condition to the decision variable as well as with reference to the condition. And now we are going to be find out the value of x as well as the value of y, so that he can achieve maximum profit. That we are going to be framed as the z value. So in this slide, the original problem we are going to be convert into the formulation of the linear programming problem. For this, certain inputs are required, as we discussed. One is nothing about the decision variable, second is nothing about the condition, and third is nothing about the what is the objective function. Based on this, we are just framing as the input for the mathematical formulation for the linear programming problem. From the input from the previous slide, and now I am getting the real mathematical problem has been converted into a linear programming problem, which has been expressed in the algebraic manner, which means the objective function has been given, that is maximize z is equal to 250x plus 75y, subject to the constraint, which is otherwise called as a restriction, that is 5x plus y less than or equal to 100, x plus y less than or equal to 60. That is about the storage condition. I am going to be find out the value of x and y, which is going to be either 0 or it's going to be a positive 1. So from this help of the input, I have been derived a mathematical model, and this mathematical model I am going to be solved by either two-dimensional method or more than two-dimensional method, we have to use the concept of simplex method and become method. But since here we have only two-dimensional, I'm going to be use the graphical method and find out what is the value of x and what is the value of y, and what should be the maximum profit the dealer can be attaining. So now we are going to be solve the LPP problem through the graphical method. So first what we are going to do, in case of this problem, we already know about our objective function. They have been given with certain condition, and also we know what are the decision variable you are replacing the problem. So first we are going to be take the condition, and the condition that has been expressed in the inequality form. So that we are going to be converted into points, because for the graph we need, since we have only two dimension, we need at least 2 points. One is going to be represent for the x variable, and the second is going to be represent for the y variable. For that, the inequalities is going to be converted into points by means of taking the origin, that is 0 comma 0. The x comma y always passes through the origin. So with the help of this, I am taking the first equation 5x plus y less than or equal to 100. That is the equation number 1. So I am going to be substitute put x is equal to 0 in equation number 1. Automatically I will be getting y is equal to 100. Meanwhile, I am going to be substitute y is equal to 0. Then automatically the x I will be getting as 20. The points for the first equations are 0, 100 and 20, 0. Same way, once when it considered about the storage condition, here we have x plus y less than or equal to 60. The same procedure we are going to be adapted, x is equal to 0 and y is equal to 0. We will be getting the point which is nothing about 0, 60 as well as 60, 0. So in case of step number 1, the conditions of inequalities are going to be converted into points for drawing a graph. This is step number 1. So now I am going to be draw a graph. So for this I am going to be take x variable as well as I am going to be take y variable. So already we received the points for the condition number 1, that is the investment condition. We received 2 points. For that I am going to be mark as A, that is 0, 100, and B I am going to be mark as 20, 0. So I am going to be connected the A and B. This is nothing about the investment condition for this problem. So what is this A and B? This is the maximum limit, which means from 0 it goes up to B, from B it goes up to A. This is a feasible region. Beyond the line, the dealer will not get any profit for this investment part. So this region I am going to be considered as the feasible region. That I am going to be take it as investment condition. In the meanwhile, I am going to be take the storage condition. Again I will be having 2 points. One is nothing about C and second is nothing about D. So the storage condition will be marked by C and D, and that I am going to be connected by a dotted line, which means from O up to D and up to C, that will be focused about the storage part. So within this they will be achieving the maximum profit for the product they are going to be sell in the business. But once in case of maximization problem, we are going to be find out the feasible region where there is an intersection point takes place. So on connecting this investment condition as well as the storage condition, there is a point of intersection takes place. That is nothing about the intersection point, which I am going to be marked as the P value. That is nothing about the optimal point. So now we have to identify the region. So here the region is nothing about O. The O it goes up to B. From B it goes up to P, and B it goes up to C, and again it comes back to the origin part. This is called as the outer boundary. What do you mean by outer boundary? The outer boundary will represent about the feasible region where the dealer will be getting maximum profit. So in case of step number 2, I am going to be find out the feasible region. At the same time, I am going to be find out the optimal point, that is represent as P. So now after forming the diagram, we are going to be find the optimal point P by means of solving the two equation, that is the equation number 1 and equation number 2, that talks about the investment condition as well as the storage condition. So on solving this two equation, obviously we will be getting the value of x and the value of y, that is going to be represented as the point P. So here the point P we are getting the value as 10, 50. So after getting the point P, we are going to be write the optimal values, and we are going to be find out what is the optimal solution. So we already discussed our extreme boundaries. So that I am going to take to the tabular column. The first column will be representing the extreme points. Second column will be the what is the corresponding value the points is having. And third, I am going to be substitute the corresponding value in the given objective function, that is z is equal to 250x plus 75y. So the starting point, the origin, obviously the point is always 0, 0. So the z optimal value will be z is equal to 0. Second, the extreme point is nothing about the b. For that, we are having the coordinate equation value, that is 20, 0. So once when I substitute 20 as x and 0 as y in the objective function, I'll be getting z is equal to 5000. And third, the optimal point P, we are getting the value, corresponding value is 10, 50. I'm substituting 10 as the x value and 50 for the y value in the objective function Z, I'll be getting 6250. And last extreme point is nothing about C, the corresponding value is 0, 60. On substituting this 0 as x and 60 as y in the objective function, the Z I'll be getting as 4500. So what is the table basically informs where the dealer is getting maximum profit. So from the final table, that is step number 4, the optimal solution, the maximum profit is nothing about 6250 is the maximum profit the dealer can be getting if he is going to be sell 10 number of table and 50 number of chair. So once if he is able to sell 10 number of table and 50 number of chair, then he is getting a maximum profit of 6250. So this is the answers we are getting by use of graphical method. Thank you.